Let's get started. So the first thing that we're going to do is boot into the ISO, which I've already done here. You can see I'm working with the ISO image that was created in late March. So these instructions should hold for quite a while, but the image is usually updated. I think it's once a month. So you may have a slightly different image than me, but so the first thing you may want to do is format the disk. So you can see here I've gone ahead and listed all the block devices. The device I'm going to be installing Arch on is VDA. So since I'm in a virtual machine, the device is called VDA. It might be called on your system NVMe 0, NVMe 1. If you're using an NVMe drive, it might be SDA, SDB if you're using an HDD or an SSD. So you'll need to tweak some of these commands based on the actual block device that you're installing Arch on. So first thing I usually like to do is format the drive. You don't have to do this, but it is kind of nice just to make sure you're starting clean. So most of us are installing on an NVMe these days. So the command to format an NVMe drive is NVMe format S1, and then usually it looks something like this: NVMe 0, 1, and 1. I think would be like if it's the first NVMe on the system. I think that's usually what it's called, but you can tweak that. The way you can list all your devices, you can use the ls command. So I usually run ls with the LAH flags. You can look up in the man page what those do, but it just makes it a little more human readable and lists everything rather than just it lists hidden files as well. So you can list out what's in the dev folder. So you can see there's a lot in here, but you can list all your devices, find the NVMe drive that you're looking for, or the hard disk or whatever that you're wanting to install on. So like I said, we're going to be installing on VDA. Next thing you're going to want to do is make sure that you can list out the EFI variables to make sure that you're booted into EFI mode. So the command to do that would be ls sysfirmware EFI vars. If that returns anything, then you are booted into EFI mode and you can move forward. If that doesn't return anything, then what that means is you're likely booted using BIOS, which means you won't be able to do things like create unified kernel images and boot off of those. And so you're going to want to pause here and make sure that you are booted into UEFI mode before you move forward. Okay, so the next thing we're going to do is set up networking. So I am connected to networking. So you can verify that by just using the ping command. So you can see here I am getting a reply. You can pick any website you want. I just pinged Google. If you're not connected to networking, you're going to want, and you're trying to use Wi-Fi, you are going to need to use something like IWCTL to get connected to Wi-Fi. I'm not going to do that here simply because I'm already connected, but the instructions are fairly straightforward. To do that, you can read those on the wiki. If you want to read the man page, you should be able to pull this up and follow the instructions on how to actually get connected to a network. Alright, so now that we're connected to a network, the next thing we're going to want to do is make sure we're synchronized with NTP, so Network Time Protocol, I think is what that stands for. So we're going to use that using the timeDateCTL command. So we're going to set NTP to true, and then we can verify that we're all synchronized by running timeDateCTL, and you can see all the various times we're in. So the boot ISO boots into UTC, and you can see that our system clock is synchronized and that we've got an active NTP service. So our clock should be good as we move forward, which is important. Next, we're going to format the disk. So this is a personal preference, but what I like to use is a tool called CFDisk. You can also use FDisk. There's, I think, gparted if you're in GNOME. Anyways, there's a lot of tools that you can use to partition a disk. I personally like CFDisk, but you may like another one. So what we can do here is run CFDisk, and we're going to use, like I said, the virtual disk, so VDA. So we're going to format VDA disk. and this will wipe all the data on the disk. So you will, caveat, you want to make sure if there's anything on that disk that you want, that before you do anything with CF disk, that you've backed anything up that you care about. All right, so now it's going to ask us what to use as the label, and so we're going to pick GPT. That's the newer label. And now we're going to create two partitions. So the first one is going to be an EFI partition, which is where all of our EFIs are going to go for booting, and that one's going to be 512 megabytes. So we'll make that 512 megabytes. We'll change the type from Linux file system to EFI system. And then the remainder of the disk, we're just going to leave as a Linux file system partition. So we'll have two partitions, VDA1 and VDA2. We're going to move over to write, and this is going to write the partition table to the disk. This will destroy any data on the disk. But we'll type yes here. We're okay with wiping it out and writing the partition table. All right, that's done, and then we'll hit quit. So now you can see when we list block devices that we have two partitions on the VDA disk. Now we're going to create our file systems within the partitions. So to do that, we're going to use the makefs command. So for the first one, for the EFI files, we need that to be FAT32. That's the file system that's readable by most motherboards. So we'll make FAT32 partition on VDA1. That's the command to do that. And then for the remainder, the big partition, VDA2, we're going to encrypt that with LUKS2. So let me just briefly pause here and go over what that means. So let's see here. Okay, great. So the model that we're going to be using here is LVM on LUKS, and so what that's going to look like is we have our boot partition. It's actually not going to be -boot, it's going to be -EFI. We'll cover that when we get there. And that'll contain everything. It's unencrypted. Has to be unencrypted because it has to be readable on boot. There's nothing sensitive in that partition though. Everything else is going to be inside this LUKS2 encrypted partition, and then we're going to, within the LUKS2 encrypted partition, we're going to use LVM to create logical volumes. So you can think of these as partitions within partitions. It's not really a partition, it's a volume. So we're going to have a root in there. If you want to separate out root and home, you can. I typically don't. I usually just have within here two volumes, one for root, which has everything in it, except for the swap. And swap is functionality that's used if you run out of RAM on your system, you have a lot of stuff open. The system can start using this swap partition to make sure you don't crash your device when you run out of RAM. And it also lets you do things like hibernate, stuff like that. So swap is useful. If you don't have to have a swap partition, I typically do set one up because I like to hibernate. So anyways, we'll go back over and start formatting everything. So the way we're going to format the VDA2 partition, which is our LUKS2 partition, is we're going to use crypt setup. So we'll do crypt setup, LUKS format, dev VDA2, and this is going to completely format that second partition. And it's going to give us another warning saying, are you really sure you want to do this? Because we're going to wipe everything out. We say yes. And this is where we're going to create our passphrase. So you want to make sure this is something really strong because the encryption is only as strong as your passphrase. So if you use something weak, the encryption is rendered somewhat useless since you could just brute force it. So we'll pick a really strong passphrase here, type it in, and then it will take a second to format the drive. But now you can see that, let me list the block devices again. You can see now we've got the VDA device. Under the VDA device, we've got two partitions. We've got a FAT32 one for all of our EFI files for boot, and then we've got a LUKS2 partition underneath it. Now what we're going to do is we're going to use LVM, and we're going to actually create the physical volumes and the logical volumes underneath the LUKS2 partition. So the first thing we're going to do is we have to open up the LUKS2 partition so that we can start writing data into it. So we have to decrypt it essentially. So the way we're going to do that is we're going to run crypt setup open dev VDA2 crypt LVM. And then it's going to ask us for our passphrase that we just set up. And we're going to have to enter this every time we boot our machine. Okay, so we've decrypted the partitions and now we can start working with it. So within the LUKS2 partition, we're going to create first a physical volume. So the command to create a physical volume with LVM is pvcreate. We're going to run dev mapper crypt LVM. And now we've just successfully created a physical volume, and now within the physical volume we can create a volume group on top of it. And so the command to create a volume group is vgcreate, and we're just going to call it arch volume, and we're going to use arch volume dev mapper crypt LVM. So this will be our command to create the arch volume group crypt LVM. So we've done that. Now we've created our volume group. Now on top of the volume group, we're going to create two logical volumes. So the first one we're going to create is going to be our swap logical volume. So we'll use the command lvcreate, and we're going to make that one. The size here is up to you. Depends on how much RAM you have and how much overflow you might need above your RAM. I don't know. I usually do about 20 gigs. That's, you're going to lose hard drive space. For the larger your swap, the less drive space you've got. But you can read up on swap and figure out how much you want to use. I'm just going to use 20 gigs here. And then actually, you know what? That's what I do on a production machine. For this, because I'm working with a small virtual disk, let's use 5 gigs. And then, so we'll say 5 gigs, arch volume, and we're going to name it swap. Alright, so we've created our swap logical volume. Now we're just going to allocate all the remaining disk space to the root. And so we'll say lvcreate, and we're going to say lowercase l, 100% free, so basically give me everything that's left. Arch volume, and we're going to name it root. Okay, let's list our block devices again, and you can see there's our logical volume. So we've got the partition, which is LUKS2 encrypted VDA2. Underneath that we've got crypt LVM, and then underneath that we've got two logical volumes, swap and root. So now let's go ahead and create file systems on these logical volumes. So to do that, we're going to turn back to our friend the makefs command. So we'll say, and I'm going to use ext4. So you have a choice here. There's multiple different file systems you could pick from. ext4 doesn't have things like snapshots and checksums and things like that. If you're using this is above the scope of this video. If you're using like a multi-disk RAID setup, you may want to use something like BTRFS, because it will take checksums and do self-healing of files. If it finds a corrupt file. This is a single disk setup. I typically, for like a laptop scenario, just go with ext4. Once again, read up on it. It's up to you. So we will first we'll format arch volume root with ext4. Alright, so we have formatted that, and now we're going to mount it. So to mount that logical volume, so we can install the operating system on top of it, we're going to use the mount command. And we'll say dev arch volume root, and then we're going to mount that into -mount. That's done. Now what we're going to do is actually make the swap on our swap logical volume and turn it on, so it's available when we boot the system. So to do that, we're going to use the make swap command, dev arch volume swap. So we have set up the swap space, and now we're going to turn it on. So to do that, we'll use swap on, and you only have to do this once. It will persist. So we're going to now turn the swap on that swap logical volume. That's done. Next we're going to format and mount, well I guess we don't need to format it, we've already formatted it, but mount our EFI partition onto VDA1. So to do that, we're going to, within our mounted root partition that we created, we're going to make a new directory. So to do that, we use the make dir command, and we'll say mount EFI. So this is what we're going to mount into VDA1. So we've made that directory, and now we're going to mount that newly created directory into VDA1. So to do that, we're going to use the mount command. We're going to specify we're putting this onto VDA1, and we're going to use -mount -EFI. Alright, so that's all done, and the last thing you want to do is just make sure that you haven't messed up somewhere. It's a lot of steps, but we can verify now that you can see our VDA disk, our FAT32 formatted VDA1 partition, and you can see over on mount points, because I used the -F flag, you can see that that is mounted into -mount -EFI. Then you can see the LUKS2 partition, crypt LVM, physical volume, and then the logical volumes underneath it, swap and root. So that all looks good. So we're going to pause here and then move on. Alright, next we're going to do the fun part, which is actually install Arch. So all we've done so far is format our disk and create some file systems on top of the disk structure. But now we're actually going to get into actually installing the system. So before we do that, we're going to want to run a command called reflector, which is going to find the best mirror for our location. The reason that you would want to do this is just to make the downloads faster as we move through these next steps. So the command to do that is reflector, and I typically like to specify we want it verbose, and this is where you're going to tweak it for your own situation. So for me, I'm in the United States, so I only want to, I'm not interested in mirrors that are outside the US, so there's no reason to hit them. And then we're going to specify how current they are. So some mirrors are a little slower in getting updated than others, and so we only want to see ones that have been updated relatively recently. This is optional as well. I typically like to limit the mirrors that I use to those that use HTTPS. Some use HTTP, some use rsync. That's just personal preference. I like to make sure that all the mirrors that I've got enabled are using HTTPS. And then we're going to sort them based on the rate, so how fast I can hit those mirrors, and then we're going to save the results into etc Pacman d mirror list, and this is the file that's going to house our mirrors that we're going to use to pull all the packages down. So we'll run this. This is going to take a minute. Alright, that is complete, and so now what we're going to do is just take a look at our mirror list and make sure that everything looks like it got updated. We can do that just by using Vim. So I'm going to use Vim throughout this. You can use another text editor called Nano if you want to work with that. It can be a little easier if you're used to like Notepad in Windows or things like that. I would say if you're going to run a Unix-based operating system, it's worthwhile to learn the Vim key bindings. It can be take a little while to get used to, but it's gonna be beneficial, since a lot of things by default have those Vim key bindings in place. So Vim is outside the scope of what I'm doing here, but I'm going to use Vim to open this file up, and then you can see it did update. You can see when it was retrieved, last checked, and that it sorted the mirrors based on the speed relative to my location. So we're going to exit that, clear our screen, and then now we're going to install Arch itself. And so the way that we do this is there's a command, this is unique to Arch, is called pacstrap. So we're going to run pacstrap on our mount directory, and we're going to install the base package Linux, which is the kernel, Linux firmware, and then I typically like to install the LTS kernel. Once again, this is optional. But just in case there is a regression of some sort in the Linux stable kernel, it's good to have a backup, and so we'll run that. And then depending on if you're running an Intel or AMD based processor, you'll want to modify this. I'm running an AMD based CPU and GPU, and so I'm going to install the microcode updates from AMD. Microcode allows hardware vendors to fix things like Spectre and Meltdown and other hardware-based vulnerabilities. So microcode's where that happens. So it is important to have the microcode repositories installed, so that way you're getting the latest microcode updates from either Intel or AMD. Alright, so we're going to run this, and you can see here it's pulling down a lot of packages. It's really everything, basically all the GNU utils, so all the things like move and copy and all those nice commands that we're used to. And then also the kernel. This is just like a bare bones Linux system. So it's not enough to boot, but it does have your kernel. It has all the firmware repositories and everything else. Now that that's finished, the next thing we're going to want to do is generate our fstab file, which is going to contain the layout of our different disks that we want our operating systems to know where they are. And so the way we're going to do that is run the gen fstab command, and we're going to want to use UUIDs to do that. We're going to generate it into or using everything that's inside of dash mount, and we're going to put the file into dash mount etc fstab. So we'll run that command, and then we're going to make one small change to it. So we're going to enter into the file and make a quick edit. You don't have to do this. This is more for just kind of enhances the overall security of the system. So we're going to jump over to the fmask portion of our EFI entry, and we're going to change this value. This is beyond the scope of what I'm doing here, but masking is essentially handles the permissions. So when you're booted in, this will control what different users are able to see. You can look up how masks work, but we're going to make one small change. What this means is that everybody really can read into the EFI directory, and we want to limit that. We don't necessarily want generic users to be able to read into it. So we're going to change this from 0022 to 0137 on the fmask, and then on the dmask, which is for directories, we want to change this to 0027. So 0137, 0027, you can look up how masks work, or if you just want to take those values and drop them in. It's beyond the scope of what I want to go over here. So we'll write out those changes. And then next we're going to chroot into our actual installation. And so to do that, we're going to run arch chroot, and we're going to chroot into the mount folder, which is where we mounted our root partition. Now we are actually inside of our new system. So the first thing we're going to want to do is we're going to just want to install some text editors, because we're going to need to be able to work with text files to move forward. So to do that, we're going to use, this is the first time I think we've used it, but we're going to want to use the Pacman command. So Pacman, short for package manager, is the package manager of choice on Arch. So on Debian-based distributions, you'll use apt. On RHEL, it'd be DNF or Yum, but for Arch-based distributions, Pacman is the package manager. So I typically like to go ahead and install just these three, so Nano, VI, Vim. I don't use Nano a lot, but it is useful occasionally. So let's just install all three. And -S is the installation flag for Pacman. So we've installed our text editors. Next, we're going to localize the environment. So the first thing we're going to want to do is set up the time zone that we're in. So to do that, we're going to set up what's called a symlink. And once again, beyond the scope of this installation video, but you can look up what a symlink is. So to do that, we're going to run ln-sf, which is going to create a symlink. We're going to symlink user share zone info America Chicago into etc local time. So this is essentially going to take the value that's in the America Chicago file, and we're going to symlink it over into etc local time. So for me, I should verify I'm in Central Time Zone in the United States. You're going to want to tweak that value based on where you're actually located. Okay, so we've handled that. Next, we're going to want to set up our locales, and so to do that, we have to edit a file called etc localgen. And since I'm going to be using English, United States English, what I'm going to do is go down and find this entry here, English US UTF-8. So this is what I want to use to localize my installation. So all I'm doing is uncommenting this one line, and then I'm going to save it. Next, I'm going to create a few additional configuration files. So I'm going to echo this bit of text, lang en us UTF-8. I want to put that text string into etc locale .conf. So this file doesn't exist yet. We're going to create it. So we're basically putting a little string of text in etc locale.conf. And then we're going to echo. This is where you want to set up the host name of your system. I'm just going to call it Arch, but you can call your system whatever you want to. So we want to echo whatever you want to call your system into a file called etc hostname. And then we want to generate our locale. So to do that, we're going to run a command here called localgen, and that's going to actually generate the locales. And you can see it completed successfully. So we've now localized our installation. Next, we're going to set up our host file, which is for networking. Now, if you're a web developer, you're probably familiar with the host file. But the host file is located in etc hosts. So we're going to open that up, and you can see there's nothing in here right now. So what we want to do here is we want to map 127.0.0.1 into localhost. So when we use localhost, we're using that IP, and then we want to use the IPv6 equivalent as well. And I'm using tabs here, in case you can't tell. Most of the Linux configuration files prefer tabs. I don't know if it really matters, but I always use tabs. So for this last one, we're going to use our host name, local domain, and then our host name again. So just replace Arch with whatever you have used as your host name in this last little block here for 127.0.1.1. Alright, we're going to save that. And then now we're going to install LVM, because the system will need the LVM package installed in order to be able to read the logical volumes that we created earlier. So we're going to install LVM2. Okay, now that the boot images are created, now we're going to actually edit some boot configuration. We're going to make some changes to how the system is going to boot. So to do that, we're going to edit the makeinit CPIO file. And so to do that, we're just going to call vim, and we're going to edit makeinit cpio.conf. And this is where we're going to actually specify some hooks that are needed when we're creating our unified kernel images. And so the first thing we're going to do, this is where we have some choices to make. So for me, because I'm using systemd based boot, I'm going to replace these base and udev packages with systemd. And the benefit of doing this is you can do things like enroll a hardware-based security key to decrypt your drive. You can use the TPM to decrypt your drive. You can't do that with the base hook. And so this is beneficial for that. So we're going to replace those with systemd, and then we're going to come over to key map, and we don't need that one. We're going to replace key map and console font with SD vconsole, and that's going to give us a console. And then we're going to leave block, and we're going to put after block, we're going to use SD encrypt, and this is going to be the hook that allows us to decrypt our drive once it's recognized. And then right after SD encrypt, we're going to use LVM2, and then we're going to leave file systems and FSCK as they are. So let me just read over this real quick, make sure I didn't miss anything, and it looks good. So we're going to save this, clear our screen. Next, we're going to set a root password. So to do that, we're going to use the password command. It's going to ask us for a new password for our root account. We're actually going to deactivate this account later, but for now, let's just go ahead and set a password. Now we're going to install systemd boot. So there's a lot of different ways you can boot your system. You can use grub. There's one called refind, I think. But for me, I prefer systemd boot. It's really simple, allows you to boot straight off an EFI image. So to install systemd boot, we're going to run boot ctl install. And here, you can see, you can ignore this little warning, so you can see where it's saying EFI is world accessible. This is why we changed our fmask and dmask in the fstab file. So what that will do, this is kind of a false positive. When you boot your system, that -EFI mount point will not be readable by your user. Only root will be able to access it. That was what we did when we changed our fmask and dmask values. So you can ignore these warnings. So then what we're going to do is we're going to make a few tweaks to our systemd boot configuration. So to do that, we're going to open up EFI loader conf, and you can see here we don't really have a whole lot going on, but we're going to make some changes. So the first thing we're going to do is we're going to set the default image EFI that we want to boot. So we're going to say default arch linux-EFI, and then we're going to leave the timeout here, but we're going to change it. I don't know, I like 4 seconds. So what this is it will auto boot after 4 seconds. You can change it to whatever you want. And then we're going to change console mode here to auto. And the last thing, this is more just for general security. We don't want people who aren't us to be able to access any sort of an editor. And so we'll do that here by setting our editor value to no. And then I'm going to use tabs in this configuration as well. So let me do that. There we go. It's a little easier to read. So we've made those changes. Next, we're going to have to modify some kernel parameters. I have a little bit of a hack to do this to make it easier. So the way that you'll need the UUID of the actual VDA2 partition. You need to specify that in the kernel parameters so that the system knows where your root is actually located and what needs to be decrypted. And so the way you can get the UUID is with a command called BOKID, which lists out all the block devices and their individual UUIDs. So we want to, for me, you could write these, what we need is that UUID off of the VDA2 partition or wherever your crypt LVM partition is set up, or crypto LUKS partition is set up. So instead of having to write this down or take a picture of it or whatever, the easiest way to be able to reference that in this next step is just to pipe it into, what I like to do is just run BOK ID let's pipe that into etc. Not pipe it, sorry, append it into kernel command line. So I'm going to append the results of BLKID into this file, and then I'm going to open the file up. Okay, so now you can see I've got the results there. This is not what we actually need in this file, but this will let me copy and paste that UUID, which makes it a little easier than trying to write it down or retype it. So our actual configuration that we want in this file is, since this is a systemd based boot, we're going to use the command rd LUKS name, and then what we need here is the UUID off of the VDA2 partition. And so everything that starts with here, so what I'm doing in Vim is I'm just selecting, I use V to enter visual mode, and then I just select it over as far as I needed to, and then I'm going to yank that into the clipboard. And then I'm going to go back up to the top, come over to the end, and then I'm going to append that. Oops, I grabbed a double quote. I'm appending that to the end here, and I think I got the whole thing. So yep, I did. So that just, once again, just makes it a little easier if you actually have the UUID in the file. And then I'm going to say equals crypt LVM, and then I want to reference here where my root actually is, so the system knows where to go to boot. So we're going to say root is in dev. So this is after the partition has been decrypted. Then it will know root is in dev arch volume root, and we want to make sure to set read write permissions on that. And then I usually also set quiet because I don't want a big noisy boot process. And the same thing, I set BGRT disable. This just disables some of the noise on the screen when you're logging in. And then what I'm going to do is I'm just going to delete everything underneath that because I don't need all this in here now. In fact, it's just going to break the file. So these are kernel parameters that are used in the generation of the unified kernel images, and it's got the UUID of the partition as well as a reference to the root environment. And we'll save that. Now we're actually going to create our unified kernel images. It might be a good time to just kind of go over what a unified kernel image is and some of the benefits of using it. Let me jump back over to the wiki. Okay, so a unified kernel image is basically a single executable which can be booted directly from UEFI firmware. So instead of having a bunch of different files involved in the boot process, like a kernel image and a initRD and a bunch of other files, potentially a grub configuration and other items, you can compile is probably the wrong word, but you can combine all of these files into a single EFI and have the UEFI on your motherboard boot directly into that EFI. And then one of the big benefits of using them is that they can be signed for secure boot. So if you, I'm not going to go over secure boot on this installation since it really is for use on hardware. So what you would do in a secure boot situation is you can use a tool. There's one that I would recommend called SBCTL, which will let you enroll self-signed keys into your hardware and then sign with the self-signed keys the unified kernel image, and then you can turn on secure boot on your machine. So Arch is not signed. So by default, most computers have Microsoft's secure boot keys. Some distributions like Debian and Fedora will be signed, so they'll boot even with secure boot turned on, but Arch will not because it's not signed by Microsoft's keys, and there's politics there that I won't get into that comes up on Linux forums from time to time. But the easiest thing to do running Arch is just to sign your own files and enroll your own keys into the hardware, and then you can turn secure boot on and get that that benefit. So SBCTL is what you want. So that's the main reason that I use unified kernel images and in my boot process. So we'll go ahead and do some configuration that helps us use that in our boot process versus grub or something else. So what we're going to want to do is we will want to edit a few configuration files. So let's go into Vim, etc, make init cpiod, and then Linux preset. Okay, this is the file that we want to edit. In order to make sure make init cpio, instead of generating what it does by default, which is generating like an image and other things, is that it will generate a unified kernel image instead. So what we're going to do is we're going to uncomment this one. This is personal preference once again. I don't create fallback images. I use the LTS kernel as my fallback, and so I will delete this this section. You could do this as well if you weren't sure. If you wanted to use fallback, you can come here and just comment this out, and then let's yank that and paste it, uncomment, and then just delete fallback. There, save it. So we're just going to generate our default and not generate the fallback. That just speeds things up when you're updating your system. Next thing we're going to do is we're going to comment out this line here, and then we're going to uncomment these two. So this is going to tell make init cpio to generate the default UKI. It's going to generate it into -EFI. And then this next one, the default options, this is kind of nice. It just creates a little splash screen when it boots into it. I don't know. You don't have to use that, but it looks kind of nice. All right, and then we're going to do the same thing here. So we're going to comment that line and then uncomment that line. And I think that's all we need. Let me just double check. Yep, that's it. All right, so we're going to write that out. And then I'm going to do the exact same thing. Tell you what, then retype all that. I'm going to do that for the LTS preset as well. So basically the exact same thing. So we're going to do that, and then we're going to, rather than, I'm just going to delete this. Vim users are probably mock me for the way I'm deleting that. And then, sorry, I'm reading my notes as I'm doing this, which is usually a bad idea. So then we're going to delete that line, and then, oh no, I'm sorry, leave that one commented. Leave that one commented. Uncomment, uncomment, comment, and uncomment. So basically, yep, default UKI, default options, uncommented, fallback UKI, which we're not using, fallback options, uncommented as well, and then we're going to save that. All right, now we're going to actually generate our unified kernel images. So we're going to do make init cpio, and we'll do this a few times, so this isn't the last time we'll run this command, but what this will do is tell make init cpio to generate all unified kernel images, and then we're going to actually look inside. Yep, there's the error I was expecting. It will actually look inside the EFI folder and see what it's done. It will take a moment. Alright, so it's generated both the LTS and the regular unified kernel image successfully. So next we're going to, this is a file browser. You don't have to use this. I like it. I'm going to install a file browser called Ranger. Just makes it a little easier to browse around the system. And then I'm going to show you what we just did. Okay, so now I'm inside of our new installation, and you can see here is the EFI directory, which is on VDA1, the VDA1 partition. And what we just created when we ran the make init cpio command is it generated these UKIs. And so these right here, when we ran bootctl install, that's what generated these two EFIs. And these are going to be readable by our motherboard. So it will see these, and this is system deboot. So it will see that, it will go, I see an EFI, it will bring up system deboot, and then system deboot will go, oh, I see two EFI images here, Arch Linux LTS and Arch Linux, and it will present those to the user as options for booting. And so that's what we just did. We just put all this stuff together. Loader.conf is the file that we use to configure our system deboot options. These other ones you can just ignore. These are created by the system. All right, let's exit that. I just hit Q to exit. Let's clear the screen. All right, last thing we want to do is we want to enable a service. So this may be the first time we're using systemd's systemctl command, but this is how you manage services on Arch Linux and really most Linux distributions at this point. Again, history there that I won't get into, but this is systemd is really the default right now for managing services and processes in Linux. All right, so we are going to enable a service called systemd update service. So what that does, systemd, when you enable a service, it creates a symlink from a directory with a service file, and then usually puts it the symlink over in userlib systemd, and then it will, what this particular service does is whenever systemd is updated by the package manager, it will automatically regenerate the system deboot EFI images. So otherwise you'd have to run, let me just run it, sysboot bootctl update. That will regenerate the EFI images when systemd is updated. But if you have the service enabled, it will automatically recreate them, so you don't have to worry about it. It just automates things a little bit. But you can see it skipped it because we've already got the latest version in place. All right, let's clear our screen. This is where if you wanted to set up secure boot, which I'm not going to do because I'm doing this in a VM, you would want to refer back to the wiki. Let's go back exactly to that section of the wiki. Let me go back down. Yeah. So this is, if you're going to set up secure boot, this is where you want to go next, is read up on the sbctl package. And it's pretty straightforward to set up. So just read up on this, read as much as you can on the sbctl package, and then you can, that will create a process that signs your UKIs, and then you can turn on secure boot. Otherwise, you're going to have to leave secure boot turned off on your machine. All right, move on from there. All right, now we're going to configure Pacman, the package manager. We're going to make a few changes to the defaults. So we're going to open up Vim, or we're going to open Vim etc pacman.conf, and then we're going to change a few things. This is the configuration file that manages Pacman. I like to turn on parallel downloads. It just makes things faster. I think 5 is good. I also like to turn on color. You don't have, this is optional again. That's really the only two changes that I make to this, but this will just make the output in the terminal. It will give you some color, and then it will download. Otherwise, it's going to download one package at a time, and if you turn on parallel downloads, it just runs a little faster. So, oh, and one more thing, forgot, we want to turn on, again, this is optional, you don't have to do this, but if you want, by default, the multilib package repository is disabled or commented out, so all the software is 64-bit. If you want to be able to run 32-bit applications, you need to turn on multilib, which the main reason I turn this on is for Steam. So Steam is in multilib, it's not in the main repository, so if you want to install Steam, then you'll need to enable multilib so that you can install the package. All right, so let's save that, and then we're going to want to run Pacman. Now that we've updated the repositories that are in play, we want to update Pacman. So run pacman-sy, and now that's going to synchronize core, extra, and multilib. Now we're good to go. All right, This is optional as well. So if you're running on a laptop, there is a really useful package called TLP, which helps optimize for battery life. And so if you want to do that, you can skip this if you don't want it. But if you want to use TLP, you can install it here. I've had pretty good luck with it. We'll install it, and then we'll enable a few things and mask some other things. So we're going to use that systemctl command again to enable tlp.service. And then we're going to mask some other systemd-based commands, so that way they don't get in the way of TLP. So we're going to run systemctl mask systemd-rfkill.socket, and now it's piped systemd-rfkill.socket into devnull, which, you know, devnull in Unix-based systems is essentially the void. It doesn't do anything. It's killed essentially. So then we're gonna do the same thing. So we're gonna pipe that one into devnull as well. And now those are masked and not gonna execute. So TLP can do its thing and ramp things up and down to try to optimize for power usage and battery life. Now we're going to clear our screen. So next we're going to install video drivers and our desktop environment. So for me, I use KDE Plasma. Right now the current version is KDE Plasma 6. Plasma is the oldest desktop environment. If it looks like Windows, I mean, there's no getting around it. It's essentially a Windows UI, which that's personal preference. I like that. Others that prefer more of a Mac OS UI might like GNOME. If you really want to dive deep, try a window manager. Setting up sound and all that yourself can be a little bit of a challenge. This would probably be a 2-3 hour video if I did that. I've done it before. Don't particularly enjoy doing that, so I just install KDE, but you might enjoy that process. So next we're going to install our video drivers. So out of the box, you know, there's not any graphics card drivers installed in Arch Linux, so we need to do that. And right now, since I mentioned this is an AMD based system, I'm going to show you how to install the AMD graphics drivers. If you are using NVIDIA, it's a little bit more intense. Again, there's some politics there. NVIDIA doesn't open source their drivers, so you have to anyways install some proprietary drivers, but we'll go over AMD. So to do AMD, we'll run Pacman S and then XF86 video AMD GPU Mesa, which is the open source, kind of the big open source graphics drivers package. lib32 Mesa, this is so that our 32-bit Steam games work. Very important. Vulkan, which is kind of like graphics API, like DirectX on Windows. And then lib32 Vulkan Radeon. So this is should give us the bulk of what we need to be able to run an AMD-based GPU. And I spelled something wrong. Yep, Man instead of Vulkan. I think I did that twice, which is really funny. Yep, okay, there we go. So that looks good. Alright, now that that's installed, we are going to also enable AMD's hardware video acceleration. Let me jump back over to the wiki and just kind of briefly explain. So, hardware video acceleration. Whoop, let's make sure I'm on Chromium. Okay. So, hardware video acceleration is useful because it offloads the encode and decode of video over to the GPU and off of the CPU, and it helps you save on battery life. So it is useful to set up if you're on once again, if you're on a laptop and you're trying to optimize for power usage. It's good to kind of install these packages and make sure you've got you're taking advantage of your internal GPU, whether it's, you know, a dedicated GPU or integrated graphics. So let's just kind of go back over on onto the VM and install those packages. Alright, just to make sure we can enable hardware video acceleration. So the commands here would be Pacman S, and we're going to install libva, Mesa driver, and then the same thing, the 32-bit version as well. Oops, Mesa driver, and then VDPow. I don't know if that's how you pronounce it. That's how I say it. So Mesa VDPow, lib32, Mesa VDPow. Yep, spelled everything correctly. So this is going to give us our two libraries used in hardware video acceleration. Alright, so that's done. Next, we're going to do one more thing. We're going to install cronny, which will let us set up cron jobs. So by default, there's nothing. Cron jobs are basically a way to schedule if you're used to Windows, task scheduler. In Unix-based systems, it's usually cron jobs. So cronny is a good choice. So we'll set that up, and then let's enable it so it runs on boot. Systemdtl ctl enable cronny service. Okay, so now that's enabled, and now this is where we're going to install KDE Plasma. We could theoretically right now reboot, and we should have a bootable system. Now it's just going to bring up a TTY, and you're going to have to log in, and you're just going to get to a terminal screen because we have no desktop environment. But rather than reboot, I'm just going to go ahead and install Plasma while I'm in or ch rooted in. So to install KDE Plasma, this is the way I do it. Once again, there's different ways to do it, different meta packages and so forth, but this is the way I prefer to do it. So the package, I don't want to install all the KDE applications. So KDE has a lot of applications. Most of them I don't particularly use. There's a lot I do, but I like to install them, the ones I do use, one at a time and not install all of them. So the way you would do that is install first the Plasma meta package. This is going to just give you a bare bones KDE environment with no application. So it won't have a terminal, it won't have a web browser, it won't have email, none of that stuff. Just going to be the desktop environment, and then you can add all that stuff as you want it. It's going to ask us where do we want to get QD6 multimedia backend. Let's get it from FFmpeg, just the default. And then it's going to ask where do we want to get Jack, which is part of the Pipewire stack, which Pipewire is the Linux audio system. Jack is kind of the low latency. Most people use Pulse Audio or ALSA, is in the kernel. But Jack is in two places, so let's just get it from Pipewire since we're going to be using Pipewire with KDE. So we'll put 2 here. And then it's going to ask where we want to get TTF font. There's a few different places. Let's just take the default. And then where do we want to get emoji font? Let's, again, don't really care. Let's just take the default. Alright, this is going to take a minute. So this is going to install the entire desktop environment, and we're going to hit go and let this thing run. Alright, now that KDE is finished installing, let's install some of our applications that we want to use while we're inside of KDE. So I'm going to clear my screen, and let's just pick a few that we like. I'll show you all the ones that I installed, but once again, you can take or leave any of these. Arc is kind of a zip file tool. It's useful. Dolphin is the file browser, so you're probably going to want that. FileLight is useful. GwenView is an image viewer. K3B, if you don't have an optical drive, you don't need that. That's for burning CDs, which, I might be one of the only people that still does that, but I do use that. Kate is a text editor. KCalc is a calculator. Kdenlive is video editing software. It's actually how I edited this video. Cleopatra is a way to graphically manage your GPG keychain. Kmines is the whole reason you use KDE, which is for Minesweeper. So Kmines is like the open source Minesweeper. Compare is a diff tool. Console is your terminal. You're definitely going to want that or some other terminal. Krename, I like that one. It's an easy way to batch rename files. You can use that. Krita is a Illustrator tool. Crusader, file browser with a lot of advanced features for things like SFTP. Cup, I don't really remember, but because it's on my list, I'm going to install it. Go look it up. And then Network Manager, OpenVPN. This lets you, I utilize OpenVPN, and this lets you kind of manage OpenVPN within Network Manager. Network Manager is how KDE manages networking, so the networking stack like Wi-Fi and Ethernet and so forth. So if you want to make your life a little easier working with OpenVPN, you can do it graphically through this Network Manager OpenVPN package. Ocular, which I think is an ebook reader. Spectacle is a screenshot utility. And then Yakuake is, I think, how you pronounce that, but this lets you do like a drop-down terminal, which is kind of neat. So let's see if I got all those. And I spelled something wrong. FileLight I spelled wrong. So let's go back here. All the way. All the way. Yep. See if I got everything. I did. Let's let that run. Alright, that's finished. So now let's do a few more. These I have on my list as installing as dependencies. So let's talk about this versus the other one. So in Pacman, when you run just -s, it will tag the package as explicitly installed. So in the future, when you're wanting to see, what have I explicitly installed versus what's been installed by the system as a dependency, you can run Pacman QE, and that's going to show you everything you've explicitly installed. So you can see a lot of the stuff we just installed. Sometimes you want to intentionally install things as dependencies or flag them as dependencies, and that way if you remove the main package, it will automatically remove the dependency, otherwise it won't do that. And so these I know have dependencies of other things that I've already installed, and so I just want to tag these as dependent. So BUP, you can look up what that is. K-image formats, this will let you open, by default you won't be able to open like the Apple HEIF image files, so K-image formats will let you be able to open those files. Wallet Manager is another useful one. Let me just grab a few more. These are fonts, so like, it's good to have. Some applications are looking for certain fonts, and so these are all things fonts I've run across that I need, and I just know I need them based on other tools that I use. And so again, you don't have to install all of these fonts, but if you do find, it doesn't hurt anything to go ahead and install them. That way they're available. So let's see here, and then Qt6. Quick 3D, what this does, this will let you use the KDE Cube, which is kind of a gimmick, but it is kind of fun. So Quick 3D is the library that will let you kind of do the KDE Cube and spin it around. Let's see, Print Manager. Again, if you don't print, you don't need this, but this will let you manage printing within KDE. Same thing, System, Config, Printer, and then unrar is kind of useful for unraring files if you have to open up a RAR file. All right, let's try it. Let's install these. It looks like some of them were already there, so it looks like my list might be out of date, and I may not need to install these. And it looks like Noto extra fonts. Extra. Oh yeah, I have an extra in there. It's Noto fonts extra. There we go. So some of these it looks like have already been added as required dependencies, and they maybe weren't in the past, and so I had them on my list, but looks like they're already installed. Doesn't hurt anything to reinstall them. Alright, now that we've done that, we're going to set up sudo and then also add our user. So we're going to install, so sudo is not installed out of the box, so we're going to install sudo. That's what we're going to use to manage root access by our primary user. So we'll install that. Now we're going to add a user account. So we're going to run user add, and then I'm just going to call it user new. Why not? Okay. So we've just created a new user. They've got a home directory now, and then we're going to set a password for the new user. Okay, so that user has a password, and then we're going to add that user to the wheel group, which will let that user access sudo permissions. Let's see here, user new. Okay, and then we're going to run one more thing. So we're going to run the command vi sudo and uncomment the wheel command, or sorry, the wheel group, so that anybody in the wheel group can also run sudo commands. So we're going to find this line here that says uncomment to allow all members of group wheel to execute any command, and then we're going to uncomment that line and then save. And now our user new account should be able to execute commands as root. So at this point we're ready to reboot. So what I'm going to do is I'm going to exit the chroot environment. I'm going to unmount recursively everything that's mounted in dash mount, just to make sure, you know, everything's written out, it's done, it's unmounted, it's totally clean, and then we're just going to run power off. You can either run reboot or power off. Power off is shut down, reboot is reboot. I'm just going to run power off, and then I'm going to spin it back up and then be back in just a moment. Alright, I'm back. I realized even though I've done this many times, I realized I missed enabling a very critical service. So we're going to do that here, because this will happen to you. So you can see here, so we're booting off our disk now, and you can see that was system deboot that you just saw, and after 4 seconds it booted the main Arch Linux EFI, and now we're at the step where we need to decrypt our drive. And so we're going to enter in our decryption password to decrypt the drive. Now the boot process is going to find the root logical volume, and it's going to boot us into the logical volume. And you can see this is, at this point, Arch is installed. So if you get to this screen, you've got a working system. So except the only thing is we're at a TTY, which we want to be at a login manager for KDE Plasma. And I realize I didn't enable 2 key services, so we're going to do that right now. So we're going to enter in our new user here. So we're logged in as our new user, and then we're going to enable with systemctl again. We're going to enable SDDM, which is the login manager used by KDE Plasma. So GNOME uses a different one, but KDE Plasma uses SDDM, and this is the generic scary sudo warning the first time you run sudo. It's going to say, like, you know, this is very very powerful, please be careful, don't break your system. So that's okay, we know what we're doing. So we've enabled SDDM, and then we're also going to enable Network Manager, so that way networking comes online at boot, and we don't have to turn this on ourselves. It just kind of, the services all start, and if we have saved Wi-Fi networks or other networking components, that they'll be found and turned on without us doing anything. So we've enabled Network Manager and we have enabled SDDM. Let's run sudo reboot and see if we go straight into KDE Plasma now. So we've rebooted. Here's system deboot, and then we're going to enter in our decryption key. And then now we should go straight into SDDM. Yep, there it is. This is SDDM. You can see we're going to log into a Wayland session. At the time of this installation, X11 is still an option. Wayland is kind of the new display protocol. X11 is the legacy. KDE is, with the KDE 6, they've really moved a lot of stuff over to Wayland. So unless you're running like NVIDIA, which right now is still a little buggy on Wayland, you're just going to want to stick with Wayland. If you're running AMD, you're going to be fine. You won't have any problems. Well, I shouldn't say any problems. You'll be okay. All right, so let's open up, and you can see my super secure password. Once again, this is in a VM. I'd use something a little longer in real life. So we are in KDE Plasma. Fantastic. So let's skip all the tutorial stuff and do the most important thing of the entire installation, which is go over to dark mode. So I love the dark theme in KDE. Not a huge fan of the light theme. It hurts my eyes. We're going to do a couple of things now that we're actually inside of KDE. At this point, you've got a fully functional KDE system, and you can just do whatever you need to do from here. But I'm going to do a few other things. I'm going to open up console, which is the terminal that we installed. So you can see by default we're using bash, which is a great shell. I prefer ZSH. I'm not going to go over ZSH. If you want to install ZSH, it's fantastic. There's some great features and plugins like auto completion, and that's what macOS uses out of the box. But you can stick with bash too. Both of them are fine. First thing we want to check is make sure. I've had this issue in the past where the date NTP isn't turned on by default. Yeah, and you can see here we've got that. Okay, so you can see our system clock synchronization is inactive, and so the first thing we're going to want to do is turn that on. So let's go back here. You can remember we did this in the ISO before we started setting everything up, and we're just going to want to do it now that we're actually in our environment. So we're going to want to run time.ctl set NTP true. Whoops, sudo. Now that we're not logged in as root. So we're going to use sudo. What have I done? Time date. Oh, I misspelled it. Okay. Forgive me. There we go. Now it's run. Now it's go. Time date CTL status. And now we've got system clock synchronized. It's yes, and we're good to go. Next thing we're going to want to do is run reflector again now that we're actually inside of our environment. So first we have to install it. So reflector is not installed out of the box. And what reflector is going to do is find the fastest mirrors. So if we cat out the mirror list that's installed by default, let's just look at it real quick. Ooh, I cannot type. So you can see there is a mirror list in here. I don't know where this comes from or how they decide on these. Oh, it looks like I generated it already. I forgot we did that. If you did want to regenerate this, you're just going to want to make sure you have reflector installed, and then you can rerun that same command that I ran earlier where we selected, United States, sorting by rate and so forth. But it looks like this has already been done. So next, we're just going to want to verify. So this is more AMD specific. Verify all of our graphics stuff is working. There's a few utilities that I find useful in doing this. So we're going to go ahead and install them. So libva utils is a useful one just to kind of verify graphics stuff is all working. NVTop is useful. Radeon Top is AMD specific. And then VDPOW info. So we're going to install these. And again, I spelled something wrong. It is utils, not util. And so then what this will let you do, this is related to hardware video acceleration. So if you want to verify that the kernel can see everything it needs access to handle hardware video acceleration, after you've installed these packages, you should be able to run a couple of commands to do this. So the first one is va info. And again, these are going to error out because I'm inside of a VM. If you're on real hardware, this should not error. So if you get an error and you're on real hardware, then something's wrong and you need to go dig through the wiki and figure out why the kernel can't access the GPU the way that it needs to. But you should be able to run, so va info, vdpow info, and again, it's going to error out, but that's the command. If you get results, then you're good to go. The next one's glx info. This one did work, but this is to make sure it can use OpenGL. And then the last one is Vulkan info. I said Vulkman again. I don't know why I'm doing that. That's funny. So again, it's going to error out because I'm not on real hardware. But if you get results on those 4 commands, then the system can see your graphics card and use it fully. There is a trick that I had to do on my particular laptop for the VDPOW driver. This is real in the weeds, but let me go over to hardware rather than actually do it here because it's kind of meaningless in the VM. Let me go over to the hardware video acceleration wiki page and go down to where was that? Configuration, VDPAL. Yeah, so if for some reason VDPAL isn't working, you can set this environment variable inside of your system to force it to recognize it. The way you set an environment variable for, you can do it a few different ways, is you can just put a file inside of .config environment D. I'll just go ahead and do it on here so you can see it, but if for some reason VDPAL isn't working right or you're not getting the results, the way to fix it often is to set this specific environment variable. So let's go back and just put that environment variable in place, and then I'll show you how to do that in case you do have an issue with VDPAL, which I did last time I installed the system. So we'll just run this simple echo command. So we're going to echo VDPAL driver equals Radeon SI, and we're going to put that in home.config environment D envars.conf. And then now the next time we reboot, systemd will recognize that environment variable and set it to Radeon SI, and then we should be able to use hardware graphics acceleration with no issues. And then if you wanted to verify that that was in there and there wasn't something else in that file or whatever, you can always use the cat command. That's just going to read out whatever's in there, and we can see, yep, there it is. And then what we can do just to verify that everything is in there. So let's just actually, I'll just go through that. Let's reboot. So I'm going to use the graphical KDE way of rebooting. So let's just go restart. You can also do that in the terminal as well. So there is our splash screen. Decrypt the drive. Enter our password. Okay, now let's just make sure that that environment variable is in place. And so now the way you would do that is you could just run env, which is going to give you all your environment variables. Just some basic Linux stuff if you want to grep that output. And we want to just see ones that have VDPAL in there. You can see there it is. So yeah, now you can see that environment variable is set to Radeon SI. So anyways, that fixes that one little bug with AMD's hardware video acceleration. All right, so at this point we have a functioning system. We've got unified kernel images set up along with KDE Plasma. We've got some useful applications installed. And yeah, you've got a working functional system. So thanks for watching.